30 knowledgeable question about the sky. Divided into 3 parts, easy, medium, hard.
Let's test your knowledge of the sky with these 30 questions and their answers. Easy. Question: what is the Earth's atmosphere primarily composed of? Answer: nitrogen and oxygen. Question: what color does the sky typically appear to us during the day? Answer: blue. Question: what celestial body provides the most light during the day? Answer: the Sunday. Question: what is the name of the natural satellite that orbits the Earth and is visible in the night sky? Answer: the Moon. Question: what are clouds primarily made of? Answer: water droplets or ice crystals. Question: what is the phenomenon of light being scattered by particles in the atmosphere called? Answer: scattering. Question: in which direction does the sun generally appear to rise? Answer: east. Question: what is the term for a shooting star? Answer: meteor. Question: what is the band of light stretching across the night sky composed of countless stars called? Answer: the Milky Way galaxy. Question: what force keeps the Earth and other planets in orbit around the Sun? Answer: gravity. Medium. Question: why is the sky blue? Answer: blue light from the Sun is scattered more by the Earth's atmosphere than other colors because it travels as shorter, smaller waves. Question: what causes the different shapes and types of clouds we see? Answer: temperature, altitude, and the amount of water vapor in the atmosphere, as well as air currents. Question: what are the layers of the Earth's atmosphere in order from the ground up? Answer: troposphere, stratosphere, mesosphere, thermosphere, exosphere. Question: what is the difference between a meteoroid, a meteor, and a meteorite? Answer: a meteoroid is a small rocky or metallic object in space. A meteor is the streak of light seen when a meteoroid enters the Earth's atmosphere and burns up. A meteorite is a meteoroid that survives its passage through the Earth's atmosphere and impacts the Earth's surface. Question: what causes auroras like the northern lights? Answer: charged particles from the Sun interacting with the Earth's magnetic field and colliding with atoms and molecules in the upper atmosphere. Question: how does the Doppler effect relate to the light from distant galaxies? Answer: the redshift of light from distant galaxies shifting towards the red end of the spectrum indicates that they are moving away from us, similar to how the sound of a moving object changes pitch as it moves towards or away from you. Question: what is the astronomical unit O and what does it measure? Answer: an astronomical unit is the average distance between the Earth and the Sun, approximately 149.6 million kilometers. It is used to measure distances within our solar system. Question: what is the difference between apparent magnitude and absolute magnitude of a star? Answer: apparent magnitude is how bright a star appears to an observer on Earth. Absolute magnitude is the brightness a star would have if it were located at a standard distance of 10 parsecs from Earth. Question: what are constellations and how are they useful? Answer: constellations are patterns of stars that appear close together in the night sky from our perspective on Earth. They are useful for navigation, star identification, and cultural storytelling. Question: what is the process that powers the Sun and other stars? Answer: nuclear fusion, specifically the fusion of hydrogen atoms into helium in the star's core, releasing vast amounts of energy. Hard. Question: what is the significance of the Kármán line? Answer: the Kármán line, at an altitude of 100 km 62 miles above sea level, is widely recognized as the boundary between the Earth's atmosphere and outer space. Question: explain the concept of Rayleigh scattering and its dependence on wavelength. Answer: Rayleigh scattering is the elastic scattering of electromagnetic radiation including light by particles much smaller than the wavelength of the radiation. The intensity of Rayleigh scattering is inversely proportional to the fourth power of the wavelength. Lambda 4.1. This means shorter wavelengths like blue light are scattered much more strongly than longer wavelengths like red light, which is why the sky appears blue. Question: How do astronomers determine the chemical composition of distant stars? Answer: by analyzing the absorption and emission spectra of the light from the stars. Each element has a unique set of spectral lines at specific wavelengths. By identifying these lines in a star's spectrum, astronomers can determine which elements are present and their relative abundances. Question: what is the cosmic microwave background radiation and why is it important? Answer: the cosmic microwave background radiation (CMB) is faint afterglow of the Big Bang, a nearly uniform background of microwave radiation filling the universe. It is crucial evidence supporting the Big Bang theory and provides a snapshot of the universe about 380,000 years after its creation, revealing information about its early conditions and composition. Question: describe the life cycle of a main sequence star like our Sunday. Answer: a main sequence star forms from the gravitational collapse of a nebula. It spends the majority of its life fusing hydrogen into helium in its core. When the hydrogen fuel runs out in the core contracts and heats up, causing the outer layers to expand and cool, forming a red giant. Eventually, the outer layers are expelled as a planetary nebula, leaving behind a dense core called a white dwarf, which slowly cools and fades away as a black dwarf, though the universe is not yet old enough for any black dwarfs to have formed. Question: what is dark matter and what evidence suggests its existence in the universe? Answer: dark matter is a hypothetical form of matter that does not interact with light or other electromagnetic radiation, making it invisible. Its existence is inferred from its gravitational effects on visible matter, radiation, and the large-scale structure of the universe. Evidence includes the rotation curves of galaxies. Stars at the outer edges orbit faster than expected based on visible matter alone, the gravitational lensing of light around galaxy clusters, and the patterns in the cosmic microwave background radiation. Question: explain the concept of gravitational lensing. Answer: gravitational lensing is the bending of light around massive objects like galaxies or galaxy clusters due to their strong gravitational fields. This bending can distort the images of objects behind the massive object, making them appear magnified, stretched, or even multiple images. It's a powerful tool for studying the distribution of mass in the universe, including dark matter. Question: what are the different types of galaxies and how are they classified? Answer: the main types of galaxies are spiral, elliptical, and irregular. They are primarily classified based on their visual morphology, as described by the Hubble sequence, also known as the tuning fork diagram. Spiral galaxies have a central bulge and spiral arms. Elliptical galaxies are smooth, oval-shaped collections of stars. Irregular galaxies have no defined shape. There are also variations and subtypes within these main categories. Question: what is the current understanding of the expansion of the universe and the role of dark energy? Answer: the universe is currently understood to be expanding at an accelerating rate. This acceleration is attributed to a mysterious force or energy called dark energy, which makes up about 70% of the total energy density of the universe. While its exact nature is unknown, the leading theoretical explanation involves a cosmological constant or some form of vacuum energy that exerts a negative pressure, driving the expansion. Question: how do scientists detect exoplanets and what are some of the methods used? Answer: scientists use various methods to detect exoplanets, planets orbiting stars other than our Sun. Some key methods include transit photometry, detecting the slight dimming of a star's light as a planet passes in front of it; radial velocity Doppler spectroscopy, measuring the wobble of a star caused by the gravitational pull of an orbiting planet; direct imaging, taking pictures of exoplanets, which is challenging due to the faintness of the planets compared to their host stars.